Horizontal line tests are conducted when determining whether a given function has an inverse function. If a function intersects with a horizontal line at two or more points, then the inverse of the given function is not a function. Let's explore the inverse function of a quadratic function. When plotting a horizontal line, we observe that it intersects with the graph of a parabola at 2 points. Therefore, when creating an inverse function, we impose a special condition on the function, namely a restricted domain. In the case of a parabola, we set x values to be greater than or equal to 0. Step 1. Change x and y. X equals y squared. Step 2. Solve for y. Y equals plus or minus square root of x. Initially, the domain and range of the quadratic function are reversed. As a result, x is greater than or equal to 0, and y is also greater than or equal to 0. Therefore, y equals square root of x. You should choose only the positive part from the expression obtained above. We can confirm symmetry with respect to y equals x. Now, let's find the inverses of each function and determine if the inverses are functions. 1. F of x equals x cubed. Step 1. Change x and y. X equals y cubed. Step 2. Solve for y. Y equals cube root of x. The domain and range of the original function cover all real numbers, so inverse relations domain and range are unchanged. Therefore, y equals cube root of x. Graphing the original function confirms that it is defined for all real numbers, and its inverse is symmetric with respect to y equals x. 2. F of x equals square root of negative x plus 1, minus 2. Step 1. Change x and y. X equals square root of negative y plus 1, minus 2. Step 2. Solve for y. X plus 2 equals square root of negative y plus 1. X plus 2 squared equals negative y plus 1. Y equals negative x plus 2 squared plus 1. The original function's graph indicates that the domain is x is less than or equal to 1 and the range is y is greater than or equal to negative 2, they both changed. Therefore, y equals negative x plus 2 squared plus 1. Graphing the original function confirms that it is defined for the domain. The inverse function is symmetric with respect to y equals x. 3. F of x equals 1 over x plus 1 squared. Step 1. Change x and y. X equals 1 over y plus 1 squared. Step 2. Solve for y. Y plus 1 squared equals 1 over x. Y plus 1 equals plus or minus square root of 1 over x. Let's graph the original function. Conducting the horizontal line test on the original function reveals a failure. To allow for the existence of an inverse, we restrict the domain to x is greater than negative 1. So, the inverse function has restricted domain and range. Therefore, you can simply choose the positive part from the expression obtained above to form the answer. Graphing the inverse function demonstrates symmetry with respect to y equals x. Now, what happens if we reverse the conditions of the domain? In that case, you just need to select the negative part from the expression obtained above to create the answer. This also serves as the inverse function, and we can observe symmetry with respect to y equals x. For cases where the restricted domain is not initially provided, students can determine this aspect themselves. However, in most exams, the restricted domain is given, and students should adjust the graph accordingly. It's quite straightforward. See you next time.